All right, so everybody put these notes in your table of contents. All right, functions and function tables. Like I said, it's stuff you've seen before, except it's been called other things. So we're just going to make sure we all have certain terminology. So a function is a rule that you apply to your input to get your output. So some people might have called it a rule table, an input-output table, that sort of thing, because that's what it's getting. It's how you apply a rule to the input to get an output. A function table matches the input values with what the output values would be when you apply the rule. So sometimes the input-output table will be consecutive numbers. And so sometimes you can look at the output and see that, oh, every time it went up by 3 or something like that, when the input went up every time by 1. Other times they jump around a bit. So this one that you see in this first example task, it goes 2, then 4, then 5. So 4 and 5 are consecutive, but 2 to 4 isn't. So you can't necessarily look for patterns in your output. You have to see what happened to the input to get to the output, except this one gives you the rule. And that second example has 2, then 3. Those are consecutive, but then it jumps to 5. And then it has 6, which is consecutive. So don't, if they do give you 1, 2, 3, 4, don't assume the next one's 5. It might jump. Don't jump. All right, so complete the, so here example tasks dealing with function tables or input-output tables or rule tables or what's my rule and all that kind of stuff. So the first one, complete the following table using the function given. So they already gave us the function. They gave it as an algebraic equation. Y, which is our output when we look at the table, equals 5x plus 4. Who can remind us what 5x means?
5 multiplied times x.
Multiplicated? Multiplied. Yep. 5 multiplied by x. 5 times x. So we want to take the x value, that's the input value, multiply by 5, and then add 4. Order of operations again comes into play here. So I'm going to plug in a 2. I'm going to do 5 times the 2 plus the 4 to get what for my first y value here? Yep. 14. For the next one, I'm going to plug in the 4. So 5 times 4 plus 4. 24. For the next part of the input-output table, or the function table, 5 is our input. So to get the y value, I need to do 5 times the 5 plus the 4. Ben?
29.
29. Now on the next one, we have to go backwards. So we have to undo the steps. So if the last thing we did before was adding 4, the first thing we're going to do is unadd 4. What's the opposite of adding 4? Subtracting 4. So the first thing we're going to do is subtract 4. And then we're going to undo multiplying by 5. So what's the opposite of multiplying by 5? Dividing by 5. So if we take that 39 and we subtract 4 and divide by 5, what do we get as the input value?
7.
7. And then we test it out. 7 times the 5 is 35 plus the 4. When we get into, I think, Unit 6, we'll show more formally how to solve for an algebraic equation where I know what it equals. But also we could do a cover-up method, I call it. I would say 5 times what plus 4 would get me 39. So I would say 5 times, let's see, that means this whole thing here, I'm covering up the 5x. So that means this whole thing needs to be 35. 35 plus 4 would get me the 39. So therefore 5 times 7 would get me the 35 I need. So you could also work it backwards by looking at that original equation. And the last one, they want us to plug in a 10 into our equation, into our function. So we have 5 times 10 plus 4. What's going to be our output value here? 54. So sometimes they give us the rule and they ask us just to fill in the table. Sometimes it's a one-step rule, sometimes it's a multi-step rule or function. Everybody's got those notes so far? So far so good? Clearing it? Scrolling it? Trying to scroll it. Hey, come back! There we go. Another type of task that they might give us is write a rule or write a function. Write an algebraic equation, or it could be in words. Sometimes they'll specify. Write a rule that describes the relationship. Sometimes they call it a relationship. Status single. The relationship between the input, and in the function table below, that's the M, and the output. And in that function table below, that's the N. In the input-output table below. So you still might occasionally see it called input-output table. So that's why in the notes we're sort of playing around with all the different terms you might see. So who thinks they can see what's happening to get from the input value to the output value? This one's actually a single step, so it's just to give as a demonstration, as a demonstration problem, but a lot of times they're going to be multiple steps. You got to try to really play around with things, which you'll try today. Wesley?
Multiply by 3.
Multiply by 3. It didn't say it had to be as an algebraic equation. Multiply what by 3?
Multiply the input for M by 3.
Multiply the input by 3. But it wants the relationship between the input and the output value, so we'd say something like to get the output. It's not how I worded it on mine, but that's okay. My worded version on mine is you triple the input to get the output. Same sort of idea. We could, though, do it as an algebraic equation. Does anyone have an idea of what that would look like?
N equals M times 3.
Mm-hmm. N equals M times 3. Again, if you don't want to use a multiplication symbol between your variable and your number, the number would go first because it's called a coefficient, so you would say N equals 3M, and that would be valid as well. Yes, ma'am? How would you get from 2 to 6 with an exponent? In general, yep. So part of your rule could be exponents, it could be any operations, it could be multiple steps. I'm just remembering yesterday's game and how you guys make things complicated. I'd be scared to see what rules you come up with. Anyway, so that's one of the tasks it might give you. It might say, what's the rule? And the third task that I've seen quite often, based on the pattern. So sometimes they call it relationship, sometimes they call it a rule, sometimes they call it a pattern, sometimes they call it a function. So based on the pattern in the input-output table, what is the value of K Wait, what? What? Oh, and J equals 15 because it's filling in the blanks and I didn't want you coming up with the answer already, maybe. I don't know. Mine's already filled in because mine's not filling the blank version. Yeah, I'm okay now. All right, so when J's 15, what's the value of K? So therefore, we need to figure out the rule. How do we get from the J's to the K's? So it doesn't say we have to write down the rule, but we got to think about it in order to figure out what the 15 input would have as its output. So Brendan, what do you think?
Add 3.
This one's a single step again, so every time it's just adding 3. 3 plus 3 plus 3. So therefore, what's the value of K when J is 15?
18.
18. Typically, you're not going to have a single step rule or function or what have you. You're going to have multiple steps. So it's not as clear and obvious. You have to sort of do a little bit of guess and check sometimes. So you might go, okay, what happens if I double the number? How far off am I? Am I consistently a certain amount off? No, what if I take half of the number, and then how far off am I? How much would I need to add or subtract as my second step? What if I tripled it? How much would I need to add or subtract? What if I took a third of it? How much would I need to add or subtract? What if, and you sort of have to just play around with it if you don't see it right away. A lot of times it's multiple steps, so you have to double things and then see if there's another step that would always get us there, or what have you. You start.
WA is doing a cool thing where they made their own cereal and it's called Western Crunch. Just saying. It's pretty awesome.
That has what to do with what?
I'm just saying it's awesome.
All right, you have practice problems on the